Welcome in. Our objective here is to classify reactions in a different way based on how our atoms and our ions are rearranged. We can talk about synthesis reactions, decomposition reactions, single replacement, and double replacement. A synthesis reaction is one where we start with two reactants and we end up with just one product. We're just combining things together. Our example is A plus B goes to AB. Well, we can have things like sodium and chlorine combining to form just one product, sodium chloride. Calcium oxide and carbon dioxide fuse together, synthesize calcium carbonate. The opposite of this reaction is a decomposition reaction. Here we are decomposing. We're starting with a single thing, and it breaks apart into two or more pieces. This is simply the opposite of our synthesis reaction, and so you might recognize some of these as just the same as on the last slide, just written backwards. Calcium carbonate decomposing into calcium oxide and carbon dioxide. If we think back to lab from the other day, we did actually do this. We decomposed malachite into its component pieces. Next, we can talk about single displacement reactions or single replacement reactions. We have a pure element reacting with a compound. The element switches places with one of the elements in our compound. We end up with a new pure element and a new compound. Actually, we already talked about this in the context of oxidation reduction reactions. These are always those redox reactions. An element and a compound forming a new element and a new compound. And our last type of reaction, we can have double displacement reactions. This is when we have two, usually ionic compounds reacting with each other. The cations from each compound switch places. We end up with two new ionic compounds. This is like our precipitation reactions from before, or like our acid-base neutralization reactions, or like our gas evolution reactions. This is our common scheme that we already have a strategy for, and we already were starting to call it double displacement. There we go. That's our plan. A new way to classify our reactions. We have some practice problems here. We can try to classify all of our reactions in, well, both of our ways, whether these are synthesis, decomposition, single displacement, or double displacement. That's the new one from this video. Or we can refresh our memory from the last video, precipitation, acid-base neutralization, redox, gas evolution. There's probably going to be two answers, one from each set of categories, for each of these reactions. There we go. Quick video here, learning how to classify reactions in this new way based on, well, recognizing how the atoms or ions are rearranged. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.